Section 1.1, solving simple equations. I've got three vocabulary terms for you to start with. When I write vocabulary terms in my notes, I usually underline them so I know that they're important. The first one is equation. These vocabulary terms shouldn't be that foreign to you, whether you took 8th grade math last year or pre-algebra or principles of algebra or basically any class before Algebra 1, you've seen equations before. Okay, an equation is simply a statement that two expressions are equal. Okay, the next vocabulary term would be solution. A solution is a value that, when substituted for a variable, makes the equation true. And we'll look at solutions here in just a little bit. And then lastly, the third vocabulary term is inverse operation. Okay, inverse operations are two operations that undo each other. Something like plus and minus. Adding and subtracting undo each other. They are inverses. Or we could have multiply and divide. Those also undo each other. Okay, so there's two main sets of inverse operations that we're going to be working with, at least for the time being. So just keep those in the back of your mind. We will be using those a lot. All right, so solving equations. The key here is we have to keep the equation balanced. Okay, so think about an old scale where we got two plates and we're balanced here. Okay, so this could be something like 3x equals 18. Most of you probably know that to get rid of the 3 out in front of the x, this one right here, to get rid of that 3, we would need to divide by 3 to undo multiplying x by 3. What I'm trying to get at here is if I'm going to divide this side by 3, what happens is this side essentially becomes lighter. You can think of it that way. And if it's lighter, it's going to raise. What we want to do is keep the scale, keep this whole thing level, keep it balanced. So if I'm going to divide the left side by 3, what I need to do is I need to divide the right side by 3. Okay? And here's another way you can think about it. Whoops. Here's the rule that I kind of remember. What you do to one side, what you do, and you can put do in quotes, because that would be what operation you are performing on that equation. What you do to one side, you must do to the other. To the other. Okay, so if you do something to one side of an equation, you have to do the exact same thing to the other side. So if you divide one side by 3, you divide the other side by 3. If you add 5 to one side, you add 5 to the other side. We have to keep the equation balanced. Okay, so let's get into some examples. When I do examples, I abbreviate them EX. I don't usually underline them, but EX followed by a direction, that's the section for examples. Okay, and then I number them here. So number 1, let's solve. Let's go with x minus 3 equals 5. Okay, so now obviously the title of the section was solving simple equations. These are going to be pretty simple solutions. Okay, these aren't going to require a whole lot of work. Question here becomes, what am I doing to x? Well, if you look at the equation, what I'm doing is I am subtracting 3. So if we think about our inverse operations, the inverse of subtract would be add. We want to undo subtracting 3 by adding 3. And again, if I'm going to do it to one side, I have to do it to the other. Okay, so the minus 3, the plus 3, they cancel out. I'm left with x on the left-hand side. 5 plus 3 on the right gives me 8. If you're ever not sure if your answer is right, you can always go back in, put that right back in for x and see if you get the right answer. Let's see if 8 minus 3, whoops, I'm sorry. 8 minus 3, let's see if that is 5, and yeah, it is. 5 equals 5. We got a true statement. Okay, so that's how you can always go back and double check yourself to see if you are correct. Okay, number 2. Let's try another one here. 0.9 equals y plus 2.8. All right, here's our variable. We need to get rid of this. We are adding 2.8 to y. So to get rid of the 2.8, the adding 2.8, we need to subtract 2.8. And if I subtract 2.8 from the right-hand side, I better be subtracting 2.8 from the left-hand side. When I do that, I get an answer of negative 1.9 there. 2.8's cancel. Y. So y equals negative 1.9. Let's try another one here. How about something with fractions. Everybody loves fractions. Number 3, how about g minus 1/3 is equal to negative 2/3. G minus 1/3 is equal to negative 2/3. Again, here's g. We are subtracting 1/3. So to undo subtracting, we're going to add 1/3 to both sides, plus 1/3. Remember, when we're adding and subtracting fractions, the denominators need to be the same, and they are here, so we're in good shape. When we're adding and subtracting fractions, those go away. G equals, remember, when we're adding and subtracting fractions, if the denominators are the same, we just add or subtract the numerators. So I got negative 2 plus 1. It's like I owe $2. I pay 1 back, which means I'm still down $1. Denominator remains the same. So g equals negative 1/3. All right, let's try, let me erase this here. Let's try some with multiplying and dividing. How about 1.3x is equal to 5.2. 1.3x is equal to 5.2. Now, if you don't see an operation in between the number and the variable, the operation that we're assuming it is multiplying. So the opposite of multiplying, the inverse of multiplying, would be dividing. So I'm going to divide both sides by 1.3. I multiplied x by 1.3, so to undo that, we're going to divide both sides by 1.3. Got to divide both sides by 1.3. 1.3's cancel out, because 1.3 divided by 1.3 is 1, so I'm left with 1x is equal to, now 5.2 divided by 1.3, if you have a calculator, you can certainly use that. If you're a card player, you can see this kind of like 52 divided by 13. That should make sense, or that should set off some alarm bells, because there are 13 cards in each suit. There are 52 cards in a deck. 52 divided by 13 is 4. If you didn't know that, that's okay. Just use your calculator, that's fine. X is equal to 4. All right, let's try another one here. Number 5, how about y over 3 is equal to negative 6? Well, if we see a fraction like this, the operation that is implied is division. So to undo dividing, the opposite of that would be multiplying. So I'm going to multiply both sides by what I was originally dividing by, 3. Okay, so y divided by 3 times 3 cancel out. I'm left with y on the left-hand side. Negative 6 times 3, remember negative times positive is a negative. 6 times 3 is 18. That's about it for simple equations. This shouldn't be anything new to you. Like I said, if pre-algebra, 8th grade math, principles of algebra, you've solved equations before, especially single step or simple equations. And as we keep going here, we'll get into multi-step equations, we'll get into equations with variables on both sides with some different symbols. But this is a nice little entry into Algebra 1.